Okay, this should be a really quick little video on electric field lines. It's fairly straightforward, pretty easy to do these things. Um, it's a good way to sort of get a visual idea of what's happening in an electric field, especially when you have a system of charges. It's pretty nice way to look at what will happen to a charge placed in an electric field. So here's the rules right here. Field lines never intersect each other. Okay, that's. Let me see if I can pull this up a little more. Yeah, there you go. Field lines are perpendicular to the surface of the charge, and so even if you have a charge distribution, this is true. Field lines either go in or come out perpendicular to the charge. The magnitude of the charge and the number of field lines both are proportional to each other. So the number of lines in the magnetic or in the electric field, sorry, let's not jump ahead, is proportional to the magnitude of the charge. The start point of the field lines is at the positive charge and the end is at the negative charge. Field lines always begin on positive and end on negative. And then for field lines to either start at or end at infinity, a single charge must be used. So all that to say, field lines either begin at a charge or begin at infinity. They either end at a charge or they end at infinity. In other words, if you have a single charge, like this right here, so in a positive charge, the field lines begin on the positive charge. Note that they're all the lines coming out of the positive charge are perpendicular to the surface of it, and all of those lines end at infinity. They don't end on another charge because there is no other charge. In other words, this is the only charge in the universe as far as we're concerned. Same thing if we have a negative charge. Those lines come in from infinity and they end on the negative charge. But what happens if you have more than one charge? This is the value of doing field lines. So like for instance, in this case right here, we have two positive charges, right? And so with two positive charges, review the rules for the lines. All the field lines have to begin at the positive charge. We don't have any negative charges, so field lines don't end on charges here. So if we have a set of lines that begins on charges, but remember that one of the rules is the lines can't intersect. So where we might normally take that pattern there and just put the two things next to each other, that would create intersecting lines. And field lines don't intersect, so they bend. And then in the middle there, they bend and go up toward infinity, so that the lines will not intersect. And this, by the way, also explains why you have the repulsion between two positive charges. So what if you had a positive and a negative charge? Well, now you have the situation where the field lines still begin on the positive charge over here on the right, come out perpendicular to the surface of the charge. Notice that some of those field lines, the ones on the left, the ones on the right, these right here, do end at infinity. They don't go anywhere. But the ones on the right connect to the negative charge. And so I have lines that end on the negative charge, okay? The lines still don't intersect, all right, but they do connect. Notice that if we count the number of field lines around the positive and negative charge, let's see. I'm going to start counting, oops, didn't need to do that. I'm going to start counting up here where the line is coming in from infinity on the negative charge. Start counting on that line right there. I don't know if you can tell. Anyway, I'll count, you count, see if we get the same number. So I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 9 lines that aren't connected, if I counted that right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lines that aren't connected. Lines that are connected, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got 15 lines that are connected plus 9 lines that aren't. That's 24 total lines going into the negative charge. On the positive charge, 1, 2, 3, 4, 5, 6, 7, 8, 9 lines that aren't connected, same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 lines that are connected. So 24 lines going out of the positive charge, 24 lines going into the negative charge. What that tells me is that these charges have the same magnitude. They have the same number of field lines coming into and going out of them. They have the same magnitude. All right, what if they don't have the same magnitude? Oh, I thought there was more to it here. Well, let's see, there's a quiz. Let's start the quiz. Find out. Which of the following is a property of an electric field line? Field lines never intersect each other. That's right. Field lines are perpendicular to the surface of the charge. Uh-oh. Well, oh, I see. Field lines start at the positive charge and end at the negative charge. All of these is right. So, see if we get it right. Oh, they're not going to tell us. Which of the following is a rule for drawing electric field lines? The lines should never cross over, right? The number of field lines depend on the charge. Yes. The number of field lines are stronger when they are close to each other. That's all right. All of these. The electric field line exerting force on the charge is also known as force lines, lines of force. This is kind of a stupid question, but I would say lines of force, I guess. Because the reason that that's true is because the electric field, remember, F is equal to Q times E. So if I were to put an arbitrary positive charge in an electric field, the lines tell me the direction of the force and the size of the force that that charge would experience. So they are lines of force. The map of electric field lines provide information of electric fields of... Boy, that is a poorly worded question. The map of electric field lines provide information of the electric field of direction, strength, both of these, yes. And then what is the conventional direction of electric field? Positive to negative is right. And finish, let's see. Oh, log into it. I'm not going to do that. I'm pretty sure I got all those right, so... yeah, there's frequently asked questions. So, I was looking at another site that has those electric field lines to, maybe we can look at, I think it's this physics classroom right quick. Just look at that one right quick. And the lines that it has. It has the same kinds of things here, negative, positive, density of lines and patterns. The density of lines reveals the quantity of charge on C is greater than that on B, which is greater than that on A, because you've got more lines, literally. Two or more charges. This just kind of shows what happens. Oh, this shows how you add them up, actually. So this would show an electric field from A that shows the direction of the electric field from A and the electric field from B at different points, and what happens when you add those up. And that's why you get the field lines like we do. They don't intersect, but they kind of push each other aside. So here's what two negatively charged objects look like. Notice that the only difference between two negative charges and two positive charges, as far as the field lines go, is the direction of the lines. For positive charges, they end at infinity. From negative charges, they come in from infinity. And if we have a positively and a negatively charged, it's the same kind of thing we saw in the last one. Here's what we have when we have unequal amounts of charge. This is the only other thing I wanted to show you. So if we looked at, let's say this one right here, okay, count the lines around the left charge, and I get 1, 2, 3, 4, 5, 6. There's 6 lines around that charge. And around the right charge, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 6 lines around the left charge, 18 lines around the right charge. What does that tell us? They're both positive, so notice that the lines don't intersect, they don't overlap, they don't connect from one to the other because they're both positive charges. But the density of the lines tells us that the left charge is 1/3 of the magnitude of the right charge. So, for instance, the left charge might be a 3 microcoulomb charge, and then if that was true, the right charge would have a charge of 9 microcoulombs. Because 6 lines to 18 lines, the ratio is 18 to 6, which is 3 to 1. So the right charge has 3 times the amount of charge as the left charge in this case. Over here, I'm guessing that's going to be exactly the same, because if I look at those field patterns, the field lines, it looks like I've got the same number. So the only difference there is that they're both negatively charged. Here's a positive and a negative charge, where, man, it's a booger to count all those, but let's do it anyway. 1, 2, 3, 4 unconnected. 1, 2, 3, 4, 5, 6, 7, 8 connected. So there's a total of 12 lines around this right negative charge. Okay. And what I say, 8, 1, 2, 3, 4, 5, 6, 7, 8. Right, there's 8 lines from the positive charge that connect to there. And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23? Doesn't sound right. Maybe it's 24 and I just miscounted. You do it one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I got 23 again. So, 23 lines that don't connect plus 8 lines that do. So what's that? 31 lines around the positive charge, 12 lines around the negative charge. So the ratio of the magnitudes of these charges, the left positive charge has 31 over 12 times the amount of charge that the right negative charge does. And that's probably the same kind of thing. I mean, I guess the field lines look about the same there, but a positive instead of a negative. Positive and a negative. So there's reverse. Yeah. So let's see. There's some more little self quizzes you can do. You can go to this website and do it, physicsclassroom.com. So if you're interested in checking your knowledge on field lines, that's a good place to do it.